final video for January 21st's lecture, Math 255, and we're going to talk about functional equations for arithmetic sequences. In the previous video, we had seen something about a recursive. We had seen that an arithmetic sequence always has a sub n plus 1, a sub n plus d. That was the recursive formula. Recursive formula for an arithmetic sequence. Now what we're going to try to do is we're going to try to write it so that it doesn't depend on the previous term. We want to write it just in terms of the position number. So our goal is to write an arithmetic sequence in terms of position of previous terms, but we're going to make an exception except A0. Okay, well, let's see here. Let's go right ahead and take a look at an example here. Let's look at those odd numbers, which we know they form an arithmetic sequence. So let's write down the position. Position number is n. Here's the term, and then we're going to write it out with a formula. I'm going to write it out a little differently than I've written in the past to emphasize something a little different. So here we go. Here's our position: 0, 1, 2, 3, 4, 5, 6, 7, dot, dot, dot. Okay, so our terms: 1, 3, 5, 7, 9, 11, 13, 15. Okay, so how do I get from one to the next? Well, we know that the position, so we know what's the difference. What's the difference? Let's put that in a sort of an intermediate little thing here. Difference. We know the difference between the adjacent terms here. Those are 2's, right? 1 plus 3 is 2. Or 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9, etc. So we've got those in there. So let's see, let's write out what it is. Let's see, 3 is 1 plus 2. And 5 is what? It's 3 plus 2, and 7 is 5 plus 2, and 9 is 7 plus 2, and 11 is 9 plus 2, 13 is 11 plus 2, and 15 is 13 plus 2. Okay, so that was essentially following along the recursive definition, but now let's sort of unpack this. You see this 5, I can write it out. It's 3 plus 2, but that 3 there was the previous term, so let's write it out. 1 plus 2 plus 2. Well, that 5, instead of writing it as 5, and instead of writing it as 3 plus 2, let's write it as 1 plus 2 plus 2 plus 2. Oh, bet you can see what I'm doing here. 1 plus 2 plus 2 plus 2 plus 2. And let's see here. How many 2's am I going to have here? I'm going to have 1 plus 5. 1, 2, 3, 4, 5 2's. Yeah, this sort of gets obnoxious. There's 4, 5 2's, etc. Now, what I should do then is I should group them. I've got multiplication involved here. So this is 1 plus 2 2's. This is 1 plus 3 2's. This is 1 plus 4 2's. This is 1 plus 5 2's. And now this is a lot easier. Equals, don't want to write that, but it's pretty easy to write this here. is plus 6 2's plus 7 2's. So I think we've discovered another way to write this. See, if we take this guy and take a look at it here, that 1 was the very first term. That's right there. The thing we should then look at here is we've got this, what is this 2? This 2 is the difference. So this 2 is the D. And what's 7? Oh, wait a moment here. I see a 7 on this line. That 7 there, that's the position number, n. So what this says is we can write our formula in the following way. We can write a sub n is equal to a sub 0 plus n d. Hey, that's really slick. The really nice thing here is that this n is counting up properly and sort of keeping track of things. Now, one of the things you should realize is this is one of the reasons why we chose our position number to start at 0. Because in particular, if I put in 0 for n, I get a0 is equal to a0. Hey, that's pretty cool. Otherwise, I'd have to put an n minus 1 there or something. So this guy here, this is the functional equation for an arithmetic preview for next week. If you've seen the equation of a line before, as I imagine you may have, this sort of looks like, this is sort of reminiscent of yb plus x times m, and I've written it out exactly how they line up there. So this is preview for next week. It's chapter 4. But in any event, now whenever you see a functional equation for a line, or a functional equation for an arithmetic sequence, you'll know what it means. You can also, if you have an arithmetic sequence, you can write it right down. So you can either write down the recursive equation or the functional equation, depending on what happens to be the most convenient for what you're doing. Okay, here's a reminder, don't forget to turn in your homework. On Thursday when we reconvene. If you have any questions, please come by office hours and let's talk. Or send me an email if it's real quick. I can answer email pretty quickly. Alrighty, see you